Grade them. All right. Today we're looking at a quiz that started with state what is meant by a scalar quantity and by a vector quantity. I was really hoping you guys would nail this one in particular. Okay. Open note, hopefully you're able to find some good notes there. If you put something like scalar is a quantity with magnitude only. And for vector, if you said this one is a quantity with magnitude, and it's on the tip of everybody's tongue, let's say it together. The direction, everybody said, resounding voice there. Something like that. If you said something equivalent to that, 2 out of 2. If you only got one of them, 1 out of 2. If you mix them up, 0 out of 2. Does anybody have any questions about what you wrote down, if it would earn the mark or not? Magnitude only, magnitude and direction. That's the key idea. Very sort of general learning objective. Now we've got some quantities here, and we have to identify whether it was vector or scalar. Power, haven't really studied work, energy, power. That's chapter 5, but we have seen it before. Work, energy, and power are all scalars. So S for scalar, I'll make it clear. Temperature is also a scalar quantity. Just tells us how much, right? Magnitude only. But momentum is a vector. 2 marks on this one. So if you got all 3 right, 2 marks. If you got 2 out of 3, 1 mark. If you missed 2 of them, 0. Now this one is this was the tricky one, right? Let's clear all that. So far we got 4 marks. Okay. An aircraft is traveling in wind. This is a little bit related to the essential question, right? How can we use vector addition to study the effects of wind on airplane travel? So, but we don't have a simpler one. It's like, oh, it's just a crosswind. It's going due east and the plane's going due north. It's a little bit tougher than that, right? 65-degree angle here. Maybe the first thing that you did was drew them head to tail. So like right now, they're both head to head on this point. And so you could sort of move this vector like this, right? And then the resultant would be from the tail of the first to the head of the last, so sort of pointing in this direction like that. I guess the other thing that you could have done is you could have slid this vector down, like you could have drawn it over here like this. But either way, you would sort of, sort of show that the resultant points up and to the left like that. If you drew an arrow that a ways, 1 mark. Okay.
So is it in that direction, does it have to be starting from the tail with that effect?
If you drew an arrow that goes in this direction and you put it like over here or something, or you drew it down here, it says on figure 1.2, draw an arrow. So you kind of want to, like following directions, put it somewhere around here. The key is that it's going sort of this way. Yeah.
As long as we got that direction, we're good.
Yeah, one mark, it just says draw an arrow labeled R, so I should have labeled it R, in the direction of the resultant velocity. So it's going to point sort of this way. If the wind pushes it sort of northwest and the aircraft is going due west, it's going to move a little bit northwest, right? But more west than north. You had a question back here? Like this. If you drew, so like you could have, remember, head to tail is the key here. So if this is if you wanted to place like the aircraft velocity like this. In other words, we can translate this vector in space, move it down here, and we'd still have that result. Okay, see how that's the same vector as that? Any way you look at it, the plane's going that way. If you drew an arrow like that, 1 mark. If you drew any other direction, don't give yourself the mark. I would say get in the habit of being harsh on yourself now. And like if there's any doubt in your mind, like, I'm not going to give myself the mark, This goes in the grade book as a 7-point quiz, right? Everybody just earned 50 points for having to calculate it. If you got 4 marks already, like you got 4 out of 7, okay, what's that, like a C? but it's literally worth 7 points into your grade. So these are not worth a lot of points. All right, it really is a diagnostic. Like, don't feel bad if you weren't able to calculate this. Like, it's not going to hurt your grade. It's not going to crush it. It's going to let you know, okay, I don't know this yet. All right, keep working, keep studying my notes, do more practice problems. You want to get to the point where you can kind of nail all these marks, but it takes some time, okay? And every student learns at a little bit different rate. So don't push that. Yeah. So you put it so it's like this one, and then you move this one all the way over here, and then did you connect it like this then? So that's still going the same way, right? That's a perfect way to think about it too. You could have slid this vector over this way, so now it's head to tail. Doesn't matter which order we add these in. That's the commutative property of addition. Same thing works with vectors. So you can put the vectors sort of, as long as they're head to tail, and you connect the tail of the first with the head of the last. So that this one's the tail of the wind vector to here, and then move the airplane vector like this. You're connecting the tail of the first to the head of the last. That's pointing in the same direction as this one or as this one. Lots of different ways to sort of see that. So what we need to sort of do to do this calculation, because we have to do in part, so part one is just the 1 mark for drawing that arrow. We have to determine the magnitude, right, of the resultant velocity. So let's see how we do that. This wind velocity is moving north and west a little bit, right? So we can sort of see it like this here. Now this north vector is opposite the wind velocity, which is 28 meters per second. So if I want to calculate sort of this component, right, I've got a resultant that looks like this, something like that. And so the up component comes entirely from the wind velocity, right? It's like, however you want to sort of, work with a triangle. I could translate the vector right here and say, okay, this has a component this way and that way. Or I could work with it here, has a component this way and that way. See how these are the same sort of triangle. You just sort of work with it however you like. I'm going to kind of work with the triangle. It's kind of already there. Like, there's the hypotenuse. I'm given that angle. So I'll tend to sort of make less mistakes if I just kind of work with it this way. All right. So the aircraft is already going 95 meters per second from its engines, and the wind's going to push it a little bit more west, right? That's why I add a little bit further over, from this one. This one brings me a little bit further over. Once I move it head to tail, right, you can kind of see that. So that's going to be adjacent to it. So the cosine of 65 degrees is equal to this side adjacent. Okay, we'll call that the wind in the x direction, right? Over hypotenuse, which is 28 meters per second. Right, so you see the sort of the hypotenuse of this right triangle. Fridays, we're on a time crunch, I forgot. So we got 65, take the cosine of that, trig, that's why you use the trig functions in your calculator, times 0.8. So 11.83 plus this 95, that's how much over this is going. So 11.83 component from the wind plus 95 meters per second from the airplane itself. For a total x component of 106.8. So this up component over here is opposite the 65-degree angle. So the sine of 65 equals the wind in the y over 28, right? So same hypotenuse, so the sine function. The sine of 65 is that number times 28, and we get 25.4 thereabouts. So that's the up component. So if I want to calculate this resultant now, it's going to be that quantity squared plus 106.83 squared. And then we want the square root of that. It's still 106.83. I think I undid this the last time. Let's check it again. No, I didn't hit equals between. 106.83 squared plus 25.4 squared equals, where is that? So 110. 109.8, you should have got 110 meters per second for the resultant. That was worth 2 marks right there. Yeah. Did you round it to 110? We put 109.77. I'd take away a mark and say significance. Like make a note to yourself and say, oh, significant figures that matter. Take away 1 mark for that. Or, you know, if you're like, nah, next time I will if I forget next time. But this time it wasn't fair. You know, like you kind of decide what to do. All right, add about 7. Leave them here. YouTube knows what kind of cool belts we have here.